Now we're solving equations that are logarithmic equations, and we're going to look at how to handle those. A logarithmic equation is just an equation that involves logarithms of variable expressions. All right, now here's our property of equality for logarithmic equations in algebra. If b, x, and y are positive numbers, with b not equal to 0, then log b of x equals log b of y, if and only if x is equal to y. Obviously, they have the same base, so if x equals y, then good. Here's an example. If log base 3 of x is equal to log base 3 of 8, then x is equal to 8. If x equals 8, then log base 3 of x equals log base 3 of 8. Okay, here we are. Sorry about the buzzer. When logarithmic equations have the same base on each side, it's easy to the easiest way is just to drop the log from both sides and solve the resulting equation. So we're dropping log 7 from both sides, and you have solved this type of equation since 8th grade, possibly 7th. So then we move this x over here, and we combine like terms. We get 5x minus 16 equals negative 1. Move the 16 over, that gives you 15, and then divide by 5, that gives you 3. Now with logarithmic equations, it's important to take your answer and check it out, because some answers make the equation undefined. And when that happens, then the equation just doesn't have a solution. But here we are. We have substituted our answer back in. 6 times 3 is 18, and then I wrote 3 here. 18 minus 2 is log base 7, 2, and then we get log base 7, 2. This checks, so it's all good. Okay, come over here. Now this time, instead of having a logarithm of a base, we have natural log, which is a base of e, but we drop the natural logarithm from both sides, and we do the same procedure. We take 7x minus 13, set it equal to 2x plus 17, subtract the 2x from both sides. 5x minus 13 equals 17, add the 13 to both sides, then divide by 5, that gives us 6. Now I went through that quickly because this should be almost like elementary school math for you by now. So 7 times 6 is 42. We're checking. Natural log of 42 minus 13. And 2 times 6 is 12, but we end up with natural log 29 equals natural log 29 on both sides. So that answer checks. All right, then another one, when we don't have a logarithm on both sides, we can rewrite the equation as exponential and solve. So if you recall how we do that, we take the base, this is the power, we make our loop just like we did before. So 5 to the second power equals 3x minus 8, and 5 to the second power is 25, and we solve this equation. So we add 8 to both sides, that gives me 33, x is 11. Here's the check. We just plug 11 in to see if it works. It did. All right, same thing here. Rewrite as exponential. 3 to the third power equals 2x plus 9. Remember, you're doing this. And then you're solving that equation. You get x equals 9. I'll let you look at that equation for a minute. Plug it in, and it checks. Example number 5, same thing. 4 to the 5th power, rewrite it as a exponential. Solve it. I'm going to give you a minute. 4 to the 5th power is 1024. You do have to evaluate that. Subtract 624 from both sides. Then divide by 10. You get 40. Check it. Check it out over here by plugging 40 in to x. It does check. Now, sometimes, you see this, we have a log all the way across. When that happens, we condense. Now, we had a lesson on condensing the other day. When there's a plus sign, that means they're being multiplied. So I'm taking 2 times x and writing it here. I've got log 2x equals log 2. Then I'm dropping the log from both sides, and I get 2x equals 2. And this is the check. That gives me x equals 1, and there's the check over there. But I just condensed it and then dropped the log from both sides. All right, same thing here. We're going to condense. 2 times x minus 5. Okay, then we rewrote this one as exponential. 7 to the second power is 49 equals 2x minus 10, and then add 10 to both sides. 59 equals 2x, and you get your answer of 29.5. Now, when checking this one, I would, because this is going to give you a decimal, and that's going to give you a decimal, and you see your answer is not decimal. Leave it in the calculator. Put this in, and then go plus. Put this in, and then hit equals, and it'll work. The calculator will do the correct rounding there. So you have to be careful with that. Oh, and thank you. That's all.